Hello everyone, welcome to my webinar. The reason I've decided to do this is just because it's very difficult to get out and see customers currently, just with all the issues with COVID. So I still had some information and new products that I wanted to share with everyone. So I've decided to put together this sort of self-guided webinar. So the topic today, we have just received, I guess at the end of last year, we just received access to a new style of pump for us. These are eccentric disc pumps, and the company that makes them is Mouvex. So I wanted to share some information on these for you. So what we're going to go over today, and this will be really brief and short. I know everybody's busy. I'm just going to go over how the eccentric disc pumps work and some of the key advantages, just sort of to help you with your thought process when you're thinking about what type of pump to put in for a specific application. Just give you some information that can help with that decision-making process, what to consider. And then just go over a few applications that are that we've done and are typical for eccentric disc pumps. Okay, so the Mouvex pump, it's an eccentric disc pump, and this is a type of a positive displacement pump. So a positive displacement pump basically traps a certain volume, a specific volume of fluid, and then it forces it through the pump. So this is really good if you are trying to control the flow rate, or if you want to dose a certain amount of a product, because every rotation, every RPM, every rotation will deliver a known quantity of product. So that makes it good in that regards. Looking at how they work. So on the left, you'll see some orange components. Those are actually the stationary cylinder. And in the blue, you'll see that's actually the moving disc. So what happens is the blue component actually sits inside the orange component, and it rotates around, trapping the fluid around the edge and then forcing it through. So there's actually two different designs. There's a standard seal, and we use those for applications that, chemicals or things where you don't need anything hygienic. And then there's the sealless design, and those are typically used when either a chemical compatibility can't have a seal, or in the case that you might need a hygienic design that can be cleaned. Okay, so looking at this in a little bit more detail, there is on the stationary disc, there is a inlet hole. So basically this hole actually allows the product to be sucked in from the back, and it comes through and is pushed out the front of the pump. Okay, so I'll show you that in a little bit more detail here. Try to turn the sound down on this video. So this video will show basically how the pump works, and you can see how it goes together. So there's the stationary disc, and they've just put in the moving disc. So this is the standard design here. So you can see it just moves around, and there you can see how it accomplishes that, how it makes that moving disc rotate around. Okay, so with the green lines, that's the stationary cylinder, and then the moving cylinder is one of the orange lines. They're rotating around. It basically traps the fluid in those little chambers and forces it through. Okay, so there's an inner chamber and there's an outer chamber. And as the pump goes around, it's using both of those chambers to move the fluid. That's actually really important. We'll talk about the inner chamber and outer chamber later, because the flows from the two chambers actually balance themselves out to eliminate pulsations. So you can see the product would be chased around and pushed out. And on the back there on this design, that would just get a standard motor. Okay. Now, looking at the sealless design. It's very, very similar. You can see the little chambers there that the product's going to go through. You can see the inner and outer chamber that the product would be forced along. See how it just rotates there, capturing the fluid and pushing it along. And then they'll show you a side view in a second here. So in this design, the product actually comes through a chamber at the back, and there's some bellows there. The bellows are all designed to be cleanable. There's no sharp edges or any spots where product can be caught. Okay. So we talked about the flow from the inner chamber and the outer chamber. This is really important because what it does is it balances itself out. Often, positive displacement pumps, they often provide a very pulsing flow, and this can cause issues if you're trying to, you know, put an even spray of chocolate, an even line of chocolate, or some other product, some fruit product. It can cause issues because it's flowing and stopping and flowing and stopping. So it doesn't create that nice line of product. As well, if you have a flow meter, it can cause an issue with the flow meter reading the flow properly because the pulsations can affect the flow meter. So having flow that isn't pulsing is definitely an advantage. So here you can see in the graph at the top, the red line is the flow from the outer chamber, the yellow line is the flow from the inner chamber, and then green is them combined. So what happens is it provides a very steady flow with almost imperceptible pulsations. So I'll show you that on the next video here. So here they're just dosing some glue onto some paper, and you can see the nice steady flow, right? The nice even line that is created. There's a little bit of talking in the background here. I will try to turn the volume down on that as soon as I can, but really you just want to be looking at how the flow is nice and steady, and there's no pulsations.
Okay.
Sorry about that, a little bit loud, but they'll zoom in and you can see the nice steady even flow. Perfect. Okay, and then it'll jump to another application here in 1 second. And again, you can just see nice steady flow, and you really can't see the pulsations. So that makes it very nice for specific applications. Looking now at the design, the pump is able to run dry, and it's able to create a very strong suction. So because of this, it's actually able to self-prime itself. So if you have, product in a tote or container that you need to suck out, or you need your pump to self-prime itself for some reason, an eccentric disc pump will do that. So, what it does is it just really starts pulls the product through, and then starts pushing it. So along this same line of thought, we have the ability to actually push the product out of the lines. So what it will do is once this container or tote is empty, it'll actually start sucking the air, and it'll pull the air, pull it into the pump, compress it, and push it out through the line. So what this does is it allows you to recover products. So if you have, let's say you have a product that's quite expensive, you don't want to leave any in the line, this pump will actually push that out of the lines for you. That can be a real cost savings. It can also eliminate, some companies do, water pushes or things like that to try and get the remainder of the product out of the line. But that's not needed with this pump because the pump can actually just push the product out. So we'll just, once it gets there, it'll start sucking the air, and then it'll start pushing the air, and it'll just push your lines clear. So that can really save a lot of money if you have, especially with more expensive product in the lines. For anybody dealing with a product where they need a low shear pump, they don't want the pump to whip up the product. Definitely something that is nice about the eccentric disc pump is it does operate very slowly. It does not shear your product at all. So. Just getting a little bit more in detail about the design of this product. We've already spoken about the stationary disc. It's in yellow there. And we've spoken about the blue part, the moving disc that rotates around, creating those little chambers that trap the fluid. But what we haven't spoken about is the two springs that are in the pump. So there's an axial spring and there's a radial spring, and those are really important in keeping a long life on the pump, and they actually help the pump do its jobs of sucking product up and pushing air out of the lines. So explain that just a little bit more. So here's just showing how the radial spring works. The radial spring, and it'll highlight in red there. The radial spring just allows the pump to always keep continual tight contact as that moving disc rotates around, so you don't get any product slippage back, and that allows the pump even over time to perform still as it did, when it was new. And then same thing, just different directions. So the axial spring does create force. It forces this moving disc down against the stationary disc, and that prevents any fluid from being forced out along those edges. Okay, so this nice tight fit is actually what keeps the pump working for so long, but B and C are, it's what allows it to create a strong vacuum and suck the product up. So it creates about negative 13.7 psi, so it creates a fairly strong suction, and that is what allows it to self prime. And again, those springs pushing, same idea, same thing. It's what allows it to compress the air and push the air through once the tote or whatever it's pulling from is run dry, and it can create about up to 72 psi. So it creates very strong compression and is able to push your lines clear. Okay, for applications that are hygienic, most people probably familiar. Some pumps need a bypass around the pump, and this is because the pump doesn't allow enough flow through it to actually properly clean the processes downstream. So they put a bit of a bypass for doing the CIP around those pumps. This pump actually doesn't need that, which is really amazing. So you can actually stop the pump, and you can run your CIP fluid directly through the main chamber and out through the pump. You actually run it in reverse. And the reason you do this is because it will create a little bit of turbulence in this chamber, and the force of the fluid will actually push against those springs we talked about, and they will open the pump up so that you're able to clean all of the surfaces adequately. So it does clean very well, it cleans very quickly, and it can be integrated right into your process. There is one option on their high flow series. So this actually just offsets the inlet of the fluid, and that actually creates a little bit of a rotational effect, creates a little bit more turbulence, and that allows the pump to be cleaned just a little bit faster than in the standard design. Okay, so almost finished. I just have 2 slides left for you, and this is just a quick look at some applications that we've seen these types of pumps on. They tend to be selected when you need self-priming or you want to strip the line. So more expensive products, things that you don't want to shear. There are a lot of options if you need something like a heating jacket because you're using chocolate, things like that. All of those types of things are available. It's a very well-developed product line. For things like creams, ointments, again, the hygienic, the low shear, the ability to pump thicker products, that just makes it an ideal choice for those applications. The standard design, we see that often in glue applications, paints, inks, things that are more expensive. Again, just because of the ability to strip the lines and the ability to push fairly thick products. And especially the ability, a lot of these products tend to come in smaller containers or totes to site, and this pump will actually self-prime itself and pull that product out, and lasts really long in those harsh applications. So, okay, that is all I have for you today about Mouvex and eccentric disc pumps. Just a little bit about ourselves. So I work with a company called Integral Process Equipment, and we have two offices, one in Montreal and one in Burlington. And so we mainly deal with customers in Ontario and Quebec, and we have a wide range of pumps. And as well, we have a line of mixers and agitators, filters, filter presses, instrumentation. We get into basically, everything to do with process control. So if you do want to look us up, we have a really nice website, integralpx.com. I've included my email address there, stephanie.stevenson@integralpx.com. My background is instrumentation and process control. I've been in this my entire life. And if you need any help or if you have any questions, need more information, please don't hesitate to reach out to me. Thank you very much. Have a great day.